I/O module structure. So you have to understand that the first thing that you have to understand is that the module is connected with the rest of the computer through the signal lines, right? That is, we have understood also in the previous class that our computer is connected with the rest of the computer by plugging itself to the system bus, that is address line, data lines, and address lines, data lines, and control lines. Now you have to understand that the data is buffered, okay? Data which is transferring to and from the module is buffered in the data registers, and there are status registers that provide the current status information that would tell the CPU the current status of the device. Now we have, along with the status register can also function as control registers. That means it would accept that detailed control information from the processor. Now the next thing that you have to understand is the processor and the I/O module is communicating with the help, that is the I/O logic is that logic, and the processor is going to communicate with the help of what? With the help of control lines. Then the next thing that you have to understand is that the address, each of the peripheral device has address. So I/O module has to able to recognize that address and decode this address and should understand from which device that address is being referring to. Now if you have taken an I/O module that is doing most of the detailed burdening processing things and all, such I/O module is known as I/O channel or I/O processor. And those which requires the control from other control of the CPU and all, if it required, that is, it is preemptive I/O module, then such I/O module is known as I/O controller or device controller, like USB controller, disk controller. These are the example: disk controller, USB controller, and all. So let's learn this diagram right now. So you have to understand, for understanding this diagram, you have to understand that this part, I am going to say that this is part my computer part, computer interface to my computer system is coming in here, okay? Then this is my external devices interface part, external devices here. We know in between the computer system, let me write system here, okay? I don't know why my handwriting is going like this. 1 minute. In between this computer system and external devices, I told we have our I/O module with us. Fine, we have I/O module with us. So this is the interface of the computer system with the I/O module. So this is what my I/O module, and this is the interface with the external device. Now when you consider the I/O module, the first thing you have to understand, there is I/O logic. This is our I/O logic. Now we have external interface for each of the external devices. We have this external, let's say external interface, okay? There are a lot of external interface. There is another external interface. I will write EI, external interface, for each of the devices. For if here this would connect to one device, this would be for one monitor, let us say, and this external device would be, let's say, for keyboard, like that. Understood? For each of the device there would be an external interface logic here, okay? So that means data can go between this I/O module and these external interface logic, between this I/O logic, okay? Then you have to understand that the I/O logic can communicate with the computer system through address lines, system bus address lines. That is, we have our address line here. Let us say through this address line it can communicate, or control lines are there. So the data line, we have our data buffer. So I'm data register. Told you there are two registers. We have the data register, and there is another register, that is my control, or the control register is also there, or status register is also there. So the data can go between them, between this I/O logic and this control data register. So these are the part of what our data lines. These are the part of our data lines. Now if you see the external device, the data can transfer between them. Now the control is given to what? The control of a device, what the device has to do, would be given from the I/O module. The control you will give, and this device would in turn give the status of the device. So you have to write status, the status of the device here. Understood? So here this is a clean diagram. Here you can see you have the data register, status or control lines. Okay, this is our main IO logic. This is our main IO logic. You have the address line, the control line, and this is the main interface to our system bus, that is our computer system interface, and this part is the interface to our external devices. Okay, this is the main IO module structure. This is our external device logic is there, interface logic is there. Here data can share in the two direction. Now the status of this external device you can get it from here, and whatever the device has to perform, that you can give, the control you can give from the external device logic to that device. Okay. Now in order to do IO operations, there are three techniques that you have to understand. In order to do IO operations, there are three techniques which are possible for IO operations. Computers have three methods to handle input-output operations, that is programmed IO, interpret-driven IO and DMA. Each one is differing in how much the CPU is involved here. So you have to understand that there are three techniques which are possible for doing this IO operations, and the three methods are the programmed IO, interpret driven IO and DMA. With programmed IO, what happens is that the data is exchanged between the processor and the IO module. That is, CPU is directly handling all of the communication with the IO module, and it is the one doing all the asking, checking and transferring part. We will detailedly understand, just understand a quick introduction about what is programmed IO. In programmed IO, the data transfer exchange is happening between the processor and the IO module. So the processor, that is CPU here, is doing all the work, the asking whether the device is ready or not, checking again and again if the device is ready, and then transferring. All of this asking, checking, transferring work is done by this CPU itself, and the processor executes a program that gives its direct control of the IO operation, including sensing a device status, sending a read or write command and transferring the data. Think of CPU acting like a person who personally walks to the printer, check if that printer is ready, hands it a paper, waits and do every step manually through a program instruction. So whenever its processor is executing a program that is having a direct control to IO operation, what happened is that the CPU would check the status, send the read or write command it would send, and transfer the data. All of this transfer data, like CPU would do all of the things, right? So when the CPU is handling all of the communication with the IO module, like asking, checking, transferring, if all of these things are done by the CPU itself, then such technique of IO operation is known as programmed IO, where the exchange of data is happening between the processor and the IO module. So when the processor issues a command to the IO module, it must wait until the IO operation is complete. After telling the IO module to do something, the CPU just sit and keep checking repeatedly, are you done? Are you done yet? So a loop called as a loop is basically created here, and that loop is called as pooling or busy waiting. So what happens is that the processor would issue a command. Okay, when the processor what happened, they will give a command to the IO module. So what happened is that until the IO operation has been completed, until then the processor has to sit and wait there. So a lot of waiting is happening here of the CPU, because whenever the processor sends a command to the IO module, until this IO operations is completed, until then it has to wait there. That is, after telling the IO module to do something, the CPU just sits and keep checking repeatedly, like if you are done, are you done or not. Okay, this is called as pooling or busy waiting.